Thanks, Tiernan. So I think to start with, probably let me open with a bit of a number that I think probably will make everyone in this room slightly uncomfortable. So I think if we take a step back, and I think we're all aware that AI is what we need to help us make this energy transition. The challenge is that the technology we need to decarbonize the grid is also one of the fastest growing loads on it, and that kind of brings me to data centers. And like Tin and I won't go on too much about them, but I think these are the engines behind AI and all the different AI based technologies we're using day to day in our lives, but also in industry. And now in Ireland, for example, it's already using 21% of national grid capacity. By 2030, it's likely that's going to hit closer to 48, maybe 50%, which is a scary figure that should all worry us. And I think where it gets interesting is that between now and the next 5 years, by 2030, we're going to add renewable capacity equivalent to our entire existing power generation infrastructure. So solar alone is going to double. 90, we hear from all the different energy authorities that 90% of global electricity demands going to be met by renewables. Now, whether that does or doesn't happen is a slightly separate challenge. What we really need to focus on is how can we continuously optimize today, right? So we need to move from this area where AI is kind of a nice to have and a bit of an afterthought, I think it's fair to say, in the energy industry too. It's kind of a non-negotiable. And I'll, anecdotally drop in some of the work we're doing at Artifact with our clients. I've worked in the energy industry for a number of years, particularly on gas, coal, and the phasing out of coal, and then into renewables. So a bit of a history there. But I think what we need to do is focus on where is AI actually contributing today. And I think it's fair to say that if you go to any of the top 100 energy firms globally across UK and Europe, a lot of it is still very experimental. And I think, to cut a very long story short, these are very solved problems. It's not the lack of, or as I say, it's not the maturity of the technology that's the blocker. There's a whole downstream list of other items that prevent us really operationalizing the technology, and those will get solved over time. I think there's an element of industry maturity. We need to get comfortable using it. I'll give you an anecdote. When I first, about 10 years ago, when I went to one of my first clients when I was back in Accenture, we went into an old school coal-fired power station. We were upgrading their networking system. I went in and you had all these labels on everyone's desks. Thank you for being here for 25 years, 35 years, 45 years. And, actually just making a small change really worried people. And I think, that's effectively downstream from the energy industry wants to be stable and secure. They don't like change. And AI is going to mandate an awful lot of change over the next 5 to 6 years, basically. And I think that's something that we're going to have to wrestle with and contend with. But to jump into a couple of things. So grid balancing and forecasting. So again, forecasting, a very solved problem. If you take a look at what a good example is Sweden's done, they run a dynamic tariff system that adjusts kind of every 15 minutes based on AI predictions. Now that's really clever, and they did that because they were able to optimize the calculations that were taking 10 to 12 minutes down to about 45 to 60 seconds. So again, the leaps that we've made in machine learning and AI have actually facilitated that. It's enabled that application to now be put into production. But again, it's only happened because one, the industry, the energy firms, and the people have actually been willing to take that on, and it allows the consumer to get a better price. And that's a good example of now that we can do better forecasting, it allows us to do better grid balancing as well. But again, that isn't necessarily the blocker in terms of actually running the calculation. It's a case of how do we begin taking this very, I think fair to say, old school, often out of date technology, operational technology, and making it a little bit more like the fast moving world of IT. And OT and IT have always been at those kind of crossroads of the digital world is actually very easy to automate and optimize because it's bits, ones and zeros. Physical world, being full of atoms, is significantly harder to do so because you need to have real-time insights. You need to be able to make decisions. You need to be able to trust those decisions. And I think that's really seen in predictive maintenance. So a client of mine that works in bioenergy, they are focused on building effectively a digital twin of their plant. They want to remain a lean organization, automate end to end across their entire 12 or 15 plants in Europe. Now, in order to do that, they need to have absolute confidence in everything from the weight of the material they're bringing in, the type of material, where it's come from. And then if they are able to do that, they can then see it once they put this material into the vat and it produces methane and energy after that. Actually, how can we best optimize our route? What's the best composition of material? It allows all these other dimensions to be factored into how we can better run the plant. Now, again, they're very at a cutting edge and quite ahead of their thinking and how they want to manage that. But the biggest challenge, being brutally transparent with everyone, hasn't been the algorithmic work. It hasn't been the data or AI work. It's actually been, how do we get reliable data from the physical world into the real world using sensors? Because yes, you can stick a sensor on. Is it calibrated? Does it work? Can we trust it? Do the people in some of these remote farms in Italy and Spain who are very, let's say, they're not very good with technology, how can we get them on board? So there's a big, I hate to use the word change management, but it is a very big change management effort that needs to be put in to bring these firms to where they need to be. And I think if I just touch on a couple of other things, so industrial decarbonization, we work with a lot of heavy industry firms, and it's very easy to talk about, yes, we should all decarbonize. I think everyone on the call would be familiar with that and agree with it. The challenge is that when you want to start talking about cement, steel, glass, these really heavy industry, very energy and, more importantly, heat intensive applications, you can't just electrify that. So we're beginning to wrestle with this idea of, actually, okay, we can't electrify everything. We do still need maybe some legacy fuels in the system to enable that. How can we do it? Actually, we need to optimize. And again, it's coming down to the actual optimization algorithms that you can put in place are absolutely a solved thing. They can actually be done. That's simple. It's, can we get into a plant? Can we really change their ways of working? Because it's not as simple as going in, plugging a few sensors and saying, right, we need to run this kiln at 2,000 degrees or 1,500 degrees or whatever it is. You've actually got to make sure all your supply processes, all your logistical processes around that conform to that. So it's actually a bit of a process reinvention as well, which makes companies very uncomfortable. It's not something they're willing to do. Definitely not energy industries. It's only when they're really pushed. And I think what we're hearing, at least from speaking to a number of execs over the last 18 months, has been that they're beginning to feel that squeeze, and that is absolutely coming. So we're going to see that probably manifest itself in the next 2 to 3 years. So I think if we take a bit of a step back and look at what works today, it's very narrow and applied. So forecasting, asset optimization, process control, they all work, and actually they're used fairly extensively across some of the major firms and some of the more some of the startups firms in energy. I think what's coming next, and where we really need to get to see the benefits, and by the way, this extends to pretty much all industries, not just energy, but what's coming next is kind of autonomy. So grids that self-balance, plants that self-tune, systems that basically heal before they fail. Now, there's nothing necessarily preventing us from doing that today. It is these organizational and I think these socio-technical blockers that prevent us doing it. Google actually showed us the template for doing this years ago. Like DeepMind in London, they kind of cut cooling energy in their data centers by 40%. Now, they were able to do that because they basically handed control to their AI optimization system entirely, and now that's delivering kind of ongoing 30% sustained savings, which is unbelievably impressive. But again, that's a company that leans much higher on the risk on spectrum, so to speak. And I know Matt's going to talk about that in a bit, but what we really need to focus on is that the rules don't necessarily get better over time. AI gets better, but it only works if we're willing to accept it and actually implement it and use it. And I'm not saying that we should just hand it over and have humans completely out of the loop, but we need to have a system to manage and regulate that. Otherwise, we aren't going to realize or recognize the benefits that we urgently do need to in the energy transition. So again, the blocker isn't technology, it's the governance and it's the adoption around that. So, the firms that are winning, they're not the ones with the smartest algorithm, so to speak. I think they're the ones who've really figured out how to make AI operational, and they've embedded it into their workflows. They've trained up their operators. They've begun to make them, I won't say AI native, but definitely more, they've progressed on that digital technology spectrum. They're comfortable with what technology can do and how to use it. But again, I think what I would say is that companies have to get out there and they really need to start iterating, testing, learning in bites, and then not being afraid and actually beginning to scale that up in secure chunks and really putting the work in to make this a core part of your business and not just an afterthought.